In this video, we will discuss introducing ventilation into the HVAC system. Why introduce fresh air? System design professionals and mechanical codes determine the minimum amount of fresh air which is to be introduced into the building or the room envelope. Contaminants in the building, such as carbon dioxide, must be diluted or exhausted for human comfort. The amount of fresh air introduced is a percentage of the total CFMs of the HVAC system. This is accomplished either through a mechanical damper or an economizer. The outdoor air will be mixed with the return air prior to going through the evaporator or heating part of the system. In this drawing, we have depicted where the temperature must be found in order to accurately determine the percentage of outside air is correct. Ventilation air is outside air that is intentionally brought into the building. Return air is the air drawn into the system from the space being heated or cooled. Mixed air is the outside air and return air mixed together. There are two methods for setting outside air dampers for the correct percentage of outside air required. Method number 1. This formula should only be used with greater than 20-degree delta T between the indoor and outdoor temperatures. We will use the example on the left for the indoor and outdoor temperatures. The problem is to adjust the outdoor air for 20%. Therefore, the return air will be 80%. Take the outside air dry bulb temperature. Take the return air dry bulb temperature. The formula is mixed air temperature is equal to the outdoor air temperature minus the outdoor temperature minus return air temperature times the percentage of return air. Therefore, the mixed air temperature is equal to 90 minus 90 minus 70 times 0.8. Therefore, the mixed air temperature is equal to 90 minus 20 times 0.8. Therefore, the mixed air temperature is 90 minus 16, which gives us the mixed air temperature of 74 degrees. Therefore, we need to have the 74-degree air entering the air distribution system. Method 2 is used when the actual CFMs are known. We will use the example on the left for indoor and outdoor temperatures and the CFMs. The problem: adjust the outdoor air for 20%. Return air will be 80%. Take the outside air dry bulb temperature. Take the return air dry bulb temperature. The formula is mixed air temperature is equal to the CFMs of the outdoor air times the temperature of the outdoor air plus the CFMs of the return air times the temperature of the return air divided by the CFM total, which relates to the mixed air temperature being 2,000 times 90 plus 8,000 times 70 divided by 10,000. We now go to mixed air temperature being 740,000 divided by 10,000, which gives us a mixed air temperature of 74 degrees. Therefore, we need to have 74 degrees air entering the air distribution system. You are now ready for an adjustment of the dampers. If an economizer is installed on the HVAC system, you must adjust the fresh air damper potentiometer for the opening after calculating the temperature of the mixed air. If you are using a manual damper, you must lock the damper in place after calculating the temperature of the mixed air. Each method may take several attempts to be accurate.